Hello, welcome to Topper Machine. I'm Josh Topper, and we got an interesting one for you today. In the lathe right now is an 8-inch diameter chunk of 3/16 stainless that we need to bore out to 3.5 or 3 3/4 inch diameter +2 -0 and face off, and then put a keyway in it. So we're going to go ahead and we're going to start with a spade drill. I already did the first one right here, and this one came out really well. I'm using a 3 1/4 inch spade drill for my roughing drill because I don't have anything bigger right now. I got to get this job out of here, but I ran this one just the 3 1/4 without a pilot hole, and it went good. But we're going to try it with the 3/4 inch pilot and just see how she does. So let's get drilling. All right, I was getting a little more drill wander than I like. Small drill, a lot of wander, not a big deal. So we're just gonna come in with a center drill, get myself a starter point. In fact, we'll put a little bit of our anchor lube on there, that'll help. Anchor lube is amazing in stainless steel. It's amazing in a lot of things. That should work. Okay, so I could just hear this. I knew it was going to happen today, but I wasn't expecting this much. But it is really coming down hard out here. Yeah, the driveway is starting to disappear under the water. It's a lot of rain, which is good. We need the moisture. Being in this sand country, it's kind of hard to grow anything, and this year has been very wet, and a lot of stuff has grown nicely. So yeah, an interesting little development today. I've been here living in Spooner area for 25 years. I've been coming up here a little longer than that. My grandparents lived up here, and I don't think I've ever seen a summer this wet. We had one a couple of years ago that was just about as wet, but it's really rained a lot this year, and I'm very thankful for that because we needed the moisture desperately. As you can hear, it's picking up behind me. That's just what's dripping off the roof. Pretty cool. All right, back to work. All right, here goes. Let's see if this thing will track a little better now with a bit of a pilot hole. That's looking a lot better. All right, I didn't like the way that was cutting. In stainless steel, you want a lower speed and a higher feed. So I dropped her down. I was running 250, now we're down to 180, and that's looking a lot better. we're through. All right, now the starter hole is done. It's time to deploy the horse cock. This spade drill is 3 1/4 inch diameter. This will be our starter hole. And I already plowed, like I said, through that first one over there with no problems without a starter hole. But we're gonna try it with now and see how much better it goes. All right, we got some coolant going. We're down to 90 RPM. Let's hog this thing out. Alright, so with that starter hole, I was getting a little more chatter than I wanted. So I dropped her right down to 45 RPM, and I'm feeding pretty consistently, and that's cutting just as good as it was before, but a lot faster. All right, I want to stop for a minute here and we'll take a look at these chips that are coming out. And as you can see, they want to break. I'm feeding pretty aggressively and they're trying to break, but they're just not getting there. So it's not a big deal. Some of them are breaking off nicely. We're getting nice chunks. I mean, but here's a nice little curl. The key to stainless is slow feed and steady pressure and slow speed. So you slow RPM, but a lot of pressure, and that's what's cutting this beautifully. Well, made it all the way through, and I tell you, I can't love these spade drills enough. I know I've had a few people stupidly comment on the channel how these are old technology and there's far better things out there. Well, these things work amazing, and I'd be lost without them. So let's get this faced off and then bore it to size and then move on to the next step. So one thing I found with stainless is a little bit of coolant helps a lot. Now we'll go ahead and get that going here. And I barely have it trickling out of there. That's plenty right there. All right, we're running 180 RPM and I'm feeding pretty aggressively. I'm taking 50 thou, 25 aside, but actually taking 20 thou a revolution for feed rate. So pretty aggressive, but definitely makes a good cut. I don't know if you can hear it, but our chip, our curl, is hitting our butt plug in there. So we'll get that out as soon as we get this pass done. There's our butt plug from the other end. Just a quick measurement to see roughly where we are, and we've got about 180 to go, but we're going to stop short of that and slow down our feed. I'm getting a little bit of a rough finish here that I'm not too happy with, but we got a ways to go to clean that up. So what I may do is just drop her down to 120 RPM and see if that takes that out, because stainless does like lower speeds. All right, so I sped up my spindle speed a little bit and slowed down my feed rate considerably. And we're gonna take one more pass here to try to clean up this bore, and then we'll take our finish passes and get it to size. All right, well that's smoothed out really nice, so go ahead and take a measurement, figure out where I'm at, and finish this guy up. All right, so I'm taking 5/1000ths on this pass, and then I had 15 to go. We're just gonna see where we're at with a light cut, and then finish her off. All right, let's take a look, see where we're at. Okay, so we'll go in with the bore gauge and just see what we got. Looks like we got 9 thou to go. Yeah, about 9 thou. All right, well, let's take that and get this thing done. See if I can get this where there isn't a lot of glare, but we are spot on. I actually set it at 5/10 over, and I am less than 5 under. So I am still over my 3.75 minus 0 plus 2. So we are golden. Well, I'll go ahead and get this one out of here, get the third one up, and get that one bored and ready to go, and then we'll move over on to the next phase of this. So I won't film the next one. I'm actually going to take the time and fix my camera mount. I had quite a day with the camera. Actually, when I went to start filming this, my microphone took a crap, so I got my spare microphone that was new in the box that I bought just in case. So I'm on a new microphone again. I had to fix my magnetic base once, and now I'm going to be fixing it again. So quite a day. Anyway, we'll move on to the next one. Okay, so I just got her flipped around and up against the jaws, and we're going to face off to length. And this is not the finished outside diameter. We're going to turn that afterwards. All right, I'm just going to take a couple measurements here and see where we are. And this overall length is not critical. It's only 2 decimal places on the drawing. but because we're up against the jaw, we should be within 1 to 2 thou. Yeah. So we're pretty good. We got about 20 thou to go to get to size, but to clean this up, it'll probably take that. All right, perfect. 100% cleanup. I'm just going to take my little deburring tool and just clean up this bore here. The print does not call for chamfers except for on one end, which I already did. So we'll just clean this up with a deburring tool and that'll take care of that. Okay, now that we're all faced off the length, I swapped my jaws around. I'm gripping on the inside of the bore and very lightly. And then we're using a bullnose center on the other end to push it in. And we're gonna take this OD all the way in one pass, so it's absolutely perfect. Otherwise, the only way to do this would be in the forejaw. Take roughly half or 3/4 of it, flip it around, indicate it all in, and then take the other half. So this is the best way. Well, maybe not the best way, the easiest, the quickest way, and the most profitable way. And it's still gonna give an excellent surface finish, and I'm not gonna make a mark inside that bore because I'm not gripping it that hard. So we're gonna take lighter passes. It is stainless, so we take, you know, good passes, but not too crazy. And let's, I got about 150 thou to take off the diameter, so we'll take the first pass and see how it looks. Okay, so you heard the inconsistencies as we cut. That's because this is basically a hot rolled material. So it doesn't have the mill scale like steel does, but it's basically a hot rolled. And as you can see, maybe, I can see it in my screen here on the camera, but it touched to there, and you got an outline where it come around. So it missed this spot, it missed this spot, it missed here. You got another little dimple here. Here's another one, here's a bigger spot up top. So it didn't do 100%, but that's okay. We've got enough to measure to see where we're at. And I mean, look at that surface finish, it came out beautiful. Okay, so I just need to basically look at this. I've got a good spot here across from this jaw where it cleaned up 100%. Let's see what it looks like over here. Nope, that won't work. But I'm good at this jaw. And it looks like we're 100% opposite of that. So that's a good measuring point. And it looks like we got 122 thousandths to go. So we're gonna take another 50 thou pass, because I don't wanna overtax it and run the risk of slipping in the jaws, because I'm barely gripping with the jaw. We're usually mostly the pressure of the tailstock here into the flat of the jaw, and we're just using the jaw itself to kind of center it. All right, I'm gonna try running a little faster on this pass and just see how it does. I said if it doesn't cut well, we've got a little further to go. But actually that's cutting very nice. It's throwing the chip. right, just another quick measurement, and we got 73 to go. Okay, so it doesn't call for a chamfer on this end just to break the sharp edge, so we're just going to use our 60-degree threading tool and just touch it like that. And the other end calls for a pretty good chamfer. All right, and this one's done as far as this goes. So I'll go ahead and get it out of there. We'll get the other two done, and then we'll move over to the slaughter. All right, before I get too far ahead of myself, I just want to show y'all, because somebody's gonna have a smart ass comment about how I gripped it. And I see a little mark there from the jaw, but you don't feel a thing. In fact, all the way around, yeah, I don't feel a thing. Just a little bit of a mark that's visible, but nothing wrong with that. All right, so I got the first one set up over here in the slaughter. I'll bring you in with the camera and show you what I all have and how we're gonna approach this. All right, so I got her setting on blocks down below, clamped down nice. We're gonna start with a narrower cutter, take out the center first, because otherwise that's too much torque on the cutter, and it's too tough. And I've never done stainless before in this, always steel. I did some manganese bronze. That was extremely hard stuff, but it cut well, and I'm gonna guess the stainless is gonna kind of be between steel and manganese bronze. So hopefully this goes well. This is some butyl tape laid in here to direct our oil, and we should be good to go. I've got it in the lowest gear. So let's start cutting. Okay, so I was having some issues there with my cutter, and it was just too much to take at one time. I'm gonna have to touch this up on the grinder, but I went to a narrower cutter, and this one's cutting good, so we're gonna have to step this up a little bit at a time. The stainless is just a difficult material. All right, so I just touched up my second cutter here, and what I figured out is I gotta be a little more aggressive on my feed, like 5 or 6 thou a pass, to keep this stainless cutting. So we'll go ahead and we'll see if this cutter works, and we'll get it into our finished depth. And All right, got the last cutter in there, and you know, it's interesting, the chips coming off of there. Aggressive feed, that's the only thing I can figure out. And I think we'll be okay getting this done. We'll see if this cutter will do it. Otherwise, we'll just go to a smaller cutter and creep up on it from there. There it is, all done. Well, there she is. And with the exception of a little bit of deburring, that's ready to go back to the customer. This, as far as I know, is a weld-in hub, so that's pretty much it. They're gonna weld that into whatever they're building. There are 3 of them, I got 2 more to do. And with the exception of a little bit of deburring on that keyway, we're all good. It came out beautiful. And before anybody asks in the comments, how much is a chunk of 316 stainless steel, 8-inch diameter, 7 inches long cost? It was just shy of $700 each. So that was a very expensive chunk of material. If I had screwed up somewhere, that's on me. So thank God I didn't screw up this one, but I got 2 more to go. So who knows what'll happen. So with that, thank everybody for watching, sticking with me all these years, and if you're new to the channel, thank you for joining and staying with me. A lot of cool stuff coming, and until next time, get out in your shop and get it done right the first time.